This is the second half of 5A. I don't think that we talked about the retrospective study. And a retrospective study or a case control study. So, a retrospective study can also be called a case control study. Um, is an observational study that uses data from the past, such as official records or past interviews, in which the sample naturally divides into a group of cases who engaged in the behavior under study and a group of controls who did not. So this involves, it's an observational study from the past. Okay, and it could involve interviews or maybe even records that somebody looked up in the past, in which the sample naturally divides into a group of cases who engaged in the behavior under the study and a group who didn't. So it's going to naturally divide into a group basically who participated and who didn't. And I also posted these notes that I know that I'm kind of abbreviating some of this stuff, but that says the actual notes. If you want to look at those are also on Blackboard, so you don't have to write all this stuff down. But in example 5A, it says for each of the following questions, what type of statistical study is most likely to lead to an answer and why? So it says, what is the average income of stockbrokers? Well, an observational study can tell us the average income of stockbrokers. We need only survey or observe the brokers. So yes, we can do this by an observational study. We can ask, or we can get that information of the average income. Okay, and we might collect that through data, or we might actually be able to ask, or there's ways that could actually get done. So that would be a good one. What is the average income of stockbrokers? Do seatbelts save lives? Is that something that a statistical study that we're likely to find an answer to, and why? So, well, it would be unethical to do an experiment in which some people were told to wear seatbelts and others were told not to wear them. So we couldn't do an experiment. So don't do an experiment here, because if we force people to not wear a seatbelt, then we already know that could be bad. So we don't want to do an experiment. We could do what we were talking about before at the beginning of class and do a retrospective study, which basically gathers information, or we already have some information gathered about this, right? So people who wore seatbelts in crashes represent the cases, and the people who did not wear them are the controls. So we could use information from the past that where they've already asked the people who were in a crash whether they had a seatbelt on or they were not. The people that did have a seatbelt on would be part of our study, and they would be part of our cases, and the people who didn't wear a seatbelt would be part of our controls. So we could do this retroactively and keep it safe by comparing the death rates and accidents between the cases and control, and we could learn whether seatbelts save lives. So this one could be done, okay? Can lifting weights improve runners' times in a 10,000 kilometer race? Can we figure that out? Well, we need to do an experiment to determine whether lifting weights can improve the 10K. time. One group of runners will be put on a weightlifting program, and a control group will be asked to stay away from weights. So we would have one group that was lifting weights, the other not lifting weights, and we must try to ensure that all the other aspects of the training are similar. In other words, they shouldn't be eating things that are a lot different. Other kinds of workouts, we try to not focus on doing a lot of extra stuff that would also impact this, like speed training or things like that that are extra. We're just trying to, if we really want to see if weightlifting can improve the 10-kilometer race time, we need them to not do a bunch of other stuff. We need everything else in their life to be as similar as possible. And then we can see whether the runners in the lifting group improve their times more than those in the control group. Note that we cannot use blinding in this experiment because there's no way to prevent participants from knowing whether they're lifting weights or not. So we talked about having a double-blind study where the participants don't know if they're part of the control or part of the group that's being observed, like a placebo effect. Well, that's not possible here because if you're a runner, you know whether you're lifting weights or not. So that would not be part of it. And that could possibly, so this can be done with an experiment. But there are some issues here. Mentally you might think if you're a runner, they're not letting me lift weights. That's not really fair. And these other people are, and it might affect your time mentally. Like, of course, I'm going to be slower. And so that might hurt your survey or hurt your experiment a little bit. But for the most part, yes, you could figure that out. Can a new herbal remedy reduce the severity of colds? Okay, so we could use a double-blind experiment, so the researchers don't know and the participants don't know if it's double-blind. So we want to use a double-blind experiment. Okay. In which some participants get the actual remedy while others get the placebo. So we need double-blind conditions because the severity of the cold may be affected by mood or other factors that experimenters might inadvertently influence. So we don't want the people that are measuring this to know whether the person has the herbal remedy or not. So we want a double-blind experiment, and yes, we could figure that out. Remember, in a double-blind experiment, you're going to have a third-party person that basically is able to tell you which people did the herbal remedy and which didn't. But the people that are asking the questions and doing the observing, they shouldn't know who actually took the experiment. So, yeah, all of these could be done with, we could find some statistics on every one of these and find some sort of answer. So let's talk about margin of error. If we wanted to find the margin of error, it's used to describe the confidence interval that is likely to contain the true population parameter. Okay, the margin of error in a statistical study is used to describe a confidence interval that is likely to contain the true population parameter. We find this interval by subtracting and adding the margin of error from the sample statistic obtained in the study. That is, as shown on the number line below, the confidence interval extends from sample statistic margin of error, sample statistic minus margin of error, to sample statistic plus the margin of error. So if this is our mean right here in the middle, okay, this is let's say that this class scored an average of 85% on the first test. And I said that our margin of error is 85 plus or minus 3%. Okay, so that means that this number would be 82 because I would say 85 minus 3, and then this number right here would be 88 because I would say 85 plus 3. And basically when you have this confidence interval, it basically ensures that this is the part that we're 95% sure that everybody is in this space. So if I was to say this, that means that 95% of my students would score between an 82 and an 88 on the test. Okay, an election eve poll finds that 52% of surveyed voters plan to vote with Smith, and she needs a majority. This is crazy because of all the stuff that's going on with the polls right now, but this is the example. So she needs a majority. She needs 50% to win without a runoff. So right now, she's got, this poll's finding out that she's got 52% of the votes, they think. And you'll hear them talk about this on TV when they're talking about statistics. It'll give them, this poll has a margin of error of 3 percentage points. Okay, so what that means is that we're taking the original number that we have, and we think that that number is pretty close, but we think it's really close if we were to look at our margin of error poll where they add or subtract 3 percentage points. So if you do, you want to look at both things, right? You want to look at the high part, which would be 52 plus 3, which would give us 55. And then we want to look at the low end of the poll. What happens if we were off? What if, so this, the high end of the poll basically looks like, what if we were off a little bit and she really did a little bit better? And the low end of the poll says, well, what if we were off and she did a little bit worse? So 52 minus 3 would give us 49. So this is, we're pretty much confident that with this margin of error that she's going to get between 55 and 49% of the vote. So let's go back and look at the question. It says an election eve poll finds that 52% of the surveyed voters plan to vote for Smith. She needs a majority, more than 50% to win without a runoff. Is this enough information to tell me if she's going to win? No, right? Because this is saying that she's going to score, or she's going to get between 49 and 55% of the vote. Well, and she has to have 50% to win. So if she's in this 49, she's not, so the answer is no. It's not enough information. We don't know if she's going to win by this poll, if this is our margin of error. Now, if they had a margin of error of 2 percentage points, they were confident within 2 percentage points, then yeah, because this number would have gone up to 52 minus 2, which is 50. And, well, actually, it's saying more than 50% to win. So really, not even if it was 2%, we wouldn't know for sure. But we needed more than 50, greater than 50 to win. So the answer to that question was no. That margin of error is not enough to tell us. Okay, so that is the end of Chapter 5, Section A. I'm going to go over Chapter 5, Support, next, which is going to talk about margin of error just a little bit more. Hold on one second. Let me get that pulled up.